Okay, so this is a question about the oxidation number. So let's look at this oxidation number change for mangan. For this mangan shown up here, oxygen has always 2 minus. So this one make up so 8 minus 8, and total charge is minus 1. So therefore the mangan on this side is 7 plus. And here is a mangan, become 2 plus. So the oxidation number here is changing delta in oxidation number. Is final minus initial. Final is plus 2, initial was plus 7, the difference is minus 5. So therefore the answer is B. Okay, the next problem is the balancing the redox equation, and the question, it was mentioned that note that the reaction is not balanced. So we need to figure out how many electrons are being transacted for the pairs shown up here. So it's a barium, which is a 0, solid, becomes barium 2 plus in aqueous solution, whereas the other pair is chrome 3 plus aqueous is being chrome 0, which is in solid. So in this way the chrome was oxidation number was changed from plus 3 to 0. So oxidation number was reduced, so that's a reduction, whereas the barium was 0 to 2 plus, so that's an oxidation. So this is an oxidation and this is a reduction. So in this case we have to charge the balance. So the first one up there, let me use a different color. Let me use this. So in order for 2 plus to be neutral on the other side, you need 2 electrons to cancel out. So right hand side and the left hand side to be 0 on both cases. In here, the chrome, you need 3 electrons to make this one to be 0. So now we need to complete this, because in order for this redox reaction, you need to add them up. You need to have cancel out the electrons like we did before in many redox cases. So what they looking into in this problem is, let's make this 2 electron multiply by 3, and let's have this reduction case is multiplied by 2. And then eventually this equation becomes barium 3 becomes 3 barium 2 plus 6 electron. Whereas here is a 2 chrome 3 plus 6 electron. This reduction occurs into 2 chrome 0. So that's the overall redox half reactions. If you add them together, this will be cancelled out. You will ended up getting 3 BaO 2 Cr 3 plus. Okay, I wrote that. 2 Cr3 plus becomes 3 Ba2 plus 2 chrome 0. The question is how many electrons, so they are asking about this, how many electrons, which is a 6 electrons. So answer for this one is 6 electrons. So being transaction here, and the resulting balance equation is this. Okay, so this is a quite difficult problem. Let's try to solve it. And it was saying that the redox reactions occurs in H2SO4. So in sulfuric acid, so we can use a sulfuric acid as one of the ingredients that we can use in this reaction. And the question is, what are the constants going in front of C3H8O2 and H2SO4? And this equation is not even balanced or shown up here. But we can certainly divide this equation into two pieces. One is this pair, okay, something that contains carbon. The other one is, let's say, this pair, chrome and potassium and the chrome sulfate in this pair. So we have to do this one by one. So I will choose a one shown in red as my red. So let me write as a okay. So what do I write? Is a C3H8O2. They become C3H4O4. So that's where it stands. And then I need to add to use the balanced equation to figure out what to do. So let's have a look at it. Okay, so 3 carbons on both sides. That's good. And oxygen, there are 2 oxygens. There are 4 oxygens. So therefore, oxygen balance using H2O, and I need 2 water. So oxygen, so let me write it here. Okay, carbon done, oxygen done. So now we have to end it up with the balancing the hydrogen, which is shown up here. How many hydrogen do I have? I have 4 hydrogens, and I have 8 hydrogen and 4 hydrogen. So together I have 12 hydrogen. So to make up the differences, I need 8 hydrogen. But hydrogen in a form of H+. Remember, oxygen balance using H2O. Now the hydrogen balance using H+, because this is an acidic solution. H2SO4, so acidic solution is what I can write. So, and then what final thing to charge is to do is a charge. So what about the charge? So okay, so let's balance the charge. It's a neutral on the left hand side, so I need 8 electrons to make the right hand side to be neutral. So I'm done with the carbon, I'm done with an oxygen using H2O, I'm done with the hydrogen using H+, done with the charge using electron, and this is all I balance on the first one. So let me delete that. Okay, so I'm done with the half reaction as far as a carbon containing compound is concerned. And let me move on to this second case where now this is a chrome containing one, which is a K2Cr2O7, and they become Cr2SO4 3. Okay, so those are what was given. So if you're looking at the balance route, let's look at the potassium first. There are 2 potassiums here. There are none of them, so I need to write K2. If I do the K2, and this is not going to be complete because, but as far as the K2 is concerned, this is okay, right? So now let's look at the chrome. There are 2 chromes, 2 chromes. They should be fine, okay? But now this is a little higher end concept. So H2SO4, they can dissociate into H plus SO4 2 minus, so 2H plus and 2 SO4 minus. because they can do, so this is one of the species, kind of the sulfur, oxygen 4s are bundled up, right? So then we can see I can use H2SO4 as a compound, and looking at to the opportunity to balance the SO4. So, okay, potassium done, chromium done. My next target is SO4 ion. I want to make it balance. Here I need 3 SO4, and even this one, potassium K2 SO4 is the logical choice for the one that as a counter ion, because this one is a 2 plus. We need a something as a counter ion is 2 minus. SO4 2 minus is a 1. So by doing it, I have 3 SO4 and 1 more extra. So by doing so, I can say I need a 4 H2SO4 because of there are 3 SO4 and there is a 1 SO4. So making up this, I ended up getting 4. So this is done. So now going back to basics now. Oxygen, hydrogen, and the charge. This is what is left to do. So let's look at the oxygen. How many oxygen do we have now? Given that SO4 is a bundle up as a package. So we have a 7 oxygen here. So therefore, let me use a little bit different color because it's kind of second stage. So on top of that, I need to add I need to add waters here. There's H2O to balance the water. I need 7 of them because this is a 7 water. It's a 7 oxygen, so 7 H2O. So oxygen is done. What about the hydrogen now? I have 8 hydrogen here, and I have 14 hydrogen here, right? So to balance this one out, I need 6 hydrogens in this side, so therefore 6H plus. Okay, so you balance an H using H plus. Once again, oxygen using H2O. Finally, the charges balance using electrons. How many electrons do I need? Because on the right hand side is 6 plus, on the left hand side is neutral, so you need 6 electrons on the other side. Okay, so now the first equation and the second equations are balanced. Let me clean up all the notation that I used to solve this one out. Okay, so now this is in a way the balanced equation. And then let me rewrite it one more time. So it's a C3H8O2 C3H4O4, and then I was balancing the oxygen using water. That was 2H2O, and then balancing the hydrogen using H plus and HH plus, and balancing the charge using electron and 8 electron minus. So that was the same equation that I wrote before. The second equation now is K2 Cr2O7 and 4H2SO4 and 6H plus and 6 electron minus. That will balance out, and that will be Cr2SO4 3 K2SO4 plus 7H2O. Okay, so that will be the second one, right? So let me delete this arrow. So now what do I do? Now let me pay attention to the last operation has to be, the objective has to be, in a way, electron has to be removed on both sides, and the common numbers that then make it multiply is actually 8 times 3, then make it 24 electrons, and this one is the whole thing is multiplied by 4, then make it 24 electrons. So that's the closest common numbers can be found by multiplying those numbers, and so we just add them together by doing it. This is gone. So this is really the objective of to get rid of the electrons. By doing it, you ended up getting these numbers: 3C3H8O2. And then this one becomes water is, so this becomes, let me write it here first, okay? This one becomes a 6H2O, and this becomes 24H plus. This one becomes 4. This is a 16. This is a 24H plus. This becomes a 4 times. This becomes a 28. Okay, 28 water. So now 6 waters and 28 waters. So this one goes away, and then this 28 becomes a 22. And let me use some more different colors. Okay, so what about the other one? Going on this other side. Yeah, I mean this one, I'm pretty sure this becomes 3, and so on, right? So, and this is 6. So water goes away. And then this becomes 22H2O. And then, let's see, 24H4. H plus 24H plus. So this is actually going to go away, and yeah. So this is actually what is left over. So going back. So now you ended up having 4K2Cr2O7, and this one you got 16H2SO4, and this waters are gone, this is all gone, so you're left over with this, and the other side is 3C3H4O4 and 4Cr2SO4 3 plus 4K2SO4 plus 22H2O. Okay, so we are done, and going back to the question is, what is this constant in front of C2H8O2, which is this one? That's the one. So this is a 3. And H2O, which H2SO4 in here, 16. So this is a 1. So answer for this one is an E. That will be the answer. Thank you.